The world's largest and most powerful particle accelerator, the Large Hadron Collider, has been restarted after a 3-year break for maintenance and upgrades. And scientists discovered a very interesting particle from there. Hi guys, welcome back to Not Alone, your space buddy. Today we're going to see what did scientists find in Hadron Collider, how did they find out, and how did they interact. So stay tuned until the very end to not miss any of the details. Let's get started. CERN's Large Hadron Collider physicists announced the discovery of 3 exotic particles that may help explain how quarks bind together. One particle is a pentaquark, a 5-quark hadron, and the other 2 are tetraquarks. The LHCb collaboration at CERN discovered them, which uses a 5,600-ton detector on a section of the Large Hadron Collider to study the differences between matter and antimatter. The Large Hadron Collider LHC is the world's largest and most powerful particle accelerator. It discovered the Higgs boson particle, which, along with its associated energy field, is thought to have been critical in the formation of the universe after the Big Bang 13.7 billion years ago. It started operation on September 10, 2008, and is still the most recent addition to CERN's accelerator complex. The LHC is a 27-kilometer ring of superconducting magnets with a number of accelerating structures to boost the energy of the particles as they travel. Before colliding, 2 high-energy particle beams travel at close to the speed of light inside the accelerometer. The beams travel in opposite directions in 2 separate beam pipes kept at ultra-high vacuum. A strong magnetic field maintained by superconducting electromagnets guides them around the accelerator ring. The electromagnets are constructed from coils of a special electric cable that operates in a superconducting state, efficiently conducting electricity without resistance or energy loss. This necessitates chilling the magnets to 271.3 degrees Celsius, which is colder than outer space. As a result, much of the accelerator is linked to a liquid helium distribution system which cools the magnets, as well as other supply services. The collider is contained in a circular tunnel with a circumference of 26.7 kilograms and a depth ranging from 50 to 175 meters underground. The depth variation was intentional in order to reduce the amount of tunnel that lies beneath the Jura Mountains and avoid having to excavate a vertical access shaft there. A tunnel was chosen to avoid having to purchase expensive land at the surface, which would also have an impact on the landscape, and to take advantage of the shielding against background radiation provided by the Earth's crust. The LHC's goal is to enable physicists to test the predictions of various particle physics theories, such as measuring the properties of the Higgs boson, searching for large family of new particles predicted by supersymmetric theories, and other unresolved particle physics questions. The LHCb collaboration discovered the first double-charm tetraquark, the longest-lived exotic matter particle discovered to date last year. The newly discovered particles are the latest addition to the collaboration's growing list of exotic particles. The more analyses we run, the more exotic hadrons we discover, said Niels Tuning, an LHCb physics coordinator, in a CERN release. We are living in a period of discovery comparable to the 1950s, when a particle zoo of hadrons was discovered, eventually leading to the quark model of conventional hadrons in the 1960s. We're making a particle zoo 2.0. Hadrons are strongly interacting subatomic particles made up of quarks and antiquarks. You're familiar with protons and neutrons are both hadrons. They are each made up of 3 quarks. Quarks come in 6 flavors: up, down, charm, strange, top and bottom, which can combine in different ways to make up unique particles. For example, the recently discovered pentaquark is made up of strange up, down and charmed quarks, as well as a charm antiquark. It is the first known pentaquark to contain a strange quark. The 2 new tetraquarks are a pair. One is doubly charged and the other is neutral partner. Finding new types of tetraquarks and pentaquarks and measuring their properties will assist theorists in developing a unified model of exotic hadrons, the exact nature of which is largely unknown, said LHCb spokesperson Chris Parks in a CERN release. It will also help us understand conventional hadrons better. The existence of the Higgs boson was confirmed 10 years ago, and physicists at the LHC continue to discover new particles. So far, 66 hadrons have been discovered at the collider, with the LHCb responsible for 59 of them. The third run of the LHC began on July 5th, and physicists anticipate that the very energetic collisions will provide even better data for unraveling the hidden underpinnings of our universe. Aside from the new particles produced by the collisions, there is plenty of useful data to be gleaned. The search of new particles isn't even half of what we do at LHC. Freya Bleckman, a particle physicist at the University of Hamburg and a member of the CMS and FCCEE collaborations, told Gizmodo in a video call last week. We also conduct extensive research into how matter sticks together and how these well-known nuclear forces operate on a much more detailed level. They also faced the risk of encountering problems with the thousands of magnets that keep billions of particles in a tight beam as they circle the collider tunnel beneath the Swiss-French border. Stierenberg explained that the system had to work like an orchestra because in order for the beam to go around, all these magnets have to play the right functions and the right things at the right time. The batch of LHC collisions observed at CERN between 2010 and 2013 provided proof of the long-sought Higgs boson particle's existence. Particle physicists still have a lot to learn, and the upgrades will allow them to look deeper into the hidden quantum realm than ever before. It may also aid in the discovery of the larger universe's underpinnings by allowing for a better understanding of dark matter. Dark matter is 5 times more abundant than ordinary matter, but it does not absorb, reflect, or emit light. So far, searches have come up empty. The LHC first came live on September 10, 2008, and despite a few glitches that took it offline, everything it has discovered has fit the standard model. This is the primary guiding theory of particle physics, developed in the 1970s, but it has flaws because it fails to explain some aspects of physics. Data collected during the LHC experiment appear to show that particles can behave in ways that the standard model does not explain, which also does not explain dark matter. This experiment into the decay of particles, known as beauty quarks, discovered that they turned into moons 15% less frequently than predicted. This implies that there is an unknown force at play in the universe, and many believe that it's a new type of force that is tipping the scales. The experiment will be repeated on the upgraded LHC with more sensitive equipment. The stakes are extremely high, said Dr. Mitesh Patel, a particle physicist at Imperial College London, who led the original experiment. So they need more data to show that it wasn't just a glitch in the equipment or experiment design. This latest upgrade marks the start of the LHC's third run and includes the installation of more powerful magnets that compress protons inside the collider into denser beams, increasing particle collision rates. Scientists will be able to use this to observe more and rarer events with greater precision than was previously possible. Teams from all over the world have worked together to help the Large Hadron Collider achieve record-breaking energy levels from its third physics run. The future of particle physics is bright as ever, with the high luminosity Large Hadron Collider on the horizon. With this, here comes the end of this video. Don't forget to share this with your friends and loved ones. Also, if you're new here, don't forget to subscribe to our channel for more updates.